Software-defined warfare refers to the idea that your hardware platforms are getting better uh, on a rapid, rate. So in hours and days, vice months and years, because of the deployment of software to those hardware platforms. So just like a Tesla or your refrigerator potentially gets a software update overnight, and that piece of hardware now has new functionality, we won't want to see that in the military domain.
Welcome to the Mission Matters podcast, a podcast from Shield Capital where we explore the technical opportunities and challenges of developing and deploying commercial technology to national security customers. I'm Maggie Gray.
And I'm Akil Iyer.
And we are your hosts from the investment team at Shield Capital. All views expressed by the hosts and guests on this podcast are solely their own and do not reflect the opinions of their employers or investment advice. References to any securities are for informational purposes only and do not constitute an investment recommendation or offer to provide investment advisory services. In this episode, we're joined by Justin Fanelli, the CTO of the Navy and technical lead for PEO Digital, as well as Artem Sherbinin, the CTO of the Surface Navy. Justin and Artem are two of the key technical leaders bringing the Navy into the 21st century. Now, Keel, I figure this conversation probably hit home especially hard for you based on your firsthand experience with the current state of technology in the Department of the Navy from your time as a Marine back in the day.
Yeah, thanks, Maggie. Preparing for this discussion did in fact remind me of my brief but very memorable time aboard naval shipping and really experiencing firsthand the technical challenges facing our maritime forces, whether that's planning and executing as a disaggregated force under limited communications and while having to use systems that have to survive the salt water, the extreme of the maritime space. I think what makes this conversation particularly timely is just everything happening in the world right now. Justin and Artem are at the forefront of making the Navy more lethal and capable in confined waters like the Persian Gulf and the Red Sea, as well as being able to do things like maintain presence and deter our adversaries in the vast expanses of the Pacific Ocean. And so this conversation is going to cover all of that. And I'm excited to get into the nitty-gritty details of deploying computer vision for maritime to what technology looks like in potential conflicts with peer adversaries, as well as what software-defined warfare actually means. Artem, Justin, I think this will be a little bit of a unique podcast for us. We've spent the last couple episodes really diving deep technologically into some of it, but I think we'll have a chance to kind of hit that intersection. You guys both come from deeply technical worlds, but are also involved in managing technology adoption. Before we get to the latter, though, would love to ask you both a softball question. What's the one tech area application, sort of challenge that, keeps you up at night, that you can't read enough about and that you're really trying to get your hands around?
For me, right now, resilient comms is actually finally starting to get resilient. And so resilient used to mean like two, and now we can be way more diversified in the different inputs. But I'd say that there are a lot of folks who are kind of nascent, or these communities didn't used to talk to each other. And so when I was at Davos this year, we said, it was unthinkable for the space folks and the 5G folks to have conversations just maybe 18 months ago. And so how do all of these different communities of interest blend to solve harder problems together? It's a great time to be a versatilist. And I think there are more of them coming together, and that's going to result in, to me, new protocols, new interfaces, and then ultimately new opportunities for deploying capability faster and solving effects problems in more creative ways.
If you ask two Navy people what the hardest technical problem is, the answer always comes back to integration. Integrating with like large legacy capital assets is always hard, especially if they're made by like a prime contractor using whatever it is, resilient comms, AI, software, hardware, anything. Integration will always end up being like the hard problem to solve.
Now, that said, this could be, there are reasons to believe, whispers, that this could be the golden age of integration, because of what we're seeing with generative AI, because of model context protocol and a few other things that are coming out. And so if, 70 cents on the dollar goes to integration, and folks who are using specifically on the software development side, vibe coding tools, and things like windsurf or other products to go much faster. If we level that up in a significant way for interfaces, and we can really go after the bottlenecks across the board, I would love to have someone who's listening to this podcast say, hey, we've done this for a defense application, and here is the time we've saved. We've seen one-offs, but benchmarking that and then making that the new baseline would be a real win.
So Justin, you're telling me your vision for the future of the Navy is just vibe coding our way into the future of conflict.
Uh, I am. That is another interesting topic. I think what we said was if we can 1/10 or 1/20th integration complexity based on applying solutions that we've seen other places, then perhaps the sky's the limit.
That's great, Justin. In order to do that, we actually have to get some of these applications and protocols on network, on the environments that we need to. But I concur with you. I mean, the future in which we can collapse the data fusion, ETL, network to network collaboration is pretty awesome. But I know both of you work a lot of issues related to actually deploying software and adopting technology at scale, to your point. Artem, you didn't really answer the question on integration on tech area, but is your focus still around the integration piece, or is there a specific tech area that has gotten you excited?
Uh, uh, yes, integration's always a focus. Specific tech area, you kind of hinted at it at the end there, is data integration. It's not particularly sexy. Like ETL is a somewhat of a solved problem, right? Lots of options ranging from Click to ETL Works to etc. But Foundry from Palantir. But it's a skipped step, right? The entire department is very hyped up on AI. The entire U.S. government is very hyped up on AI. None of that matters if your data isn't right and if you have not solved the data integration problem. So I would say that's my kind of favorite problem to work on, because it combines sort of all three aspects of my job: technical, policy, and like actual implementation. All three of those have a part to play there.
I want to take a step back and really set the stage here. Why does all of this matter in the first place? What is the state of geopolitics with our adversaries? What is the Navy's role in a potential conflict? And like why does it matter for us to rethink the way we design our force right now? And is there a sense of urgency?
Defense tech is really hot right now. I think that's why you guys started a podcast. And there's the reasons for defense tech being attractive to venture capital are different sometimes than I think the reasons that we need new technology, but those two are intersecting, right? If I look at the last 5 years of venture investing, you had this big peak around 2020 in SaaS, right? Software as a service things. And then it just took like a nosedive right around COVID. That money had to go somewhere, and it conveniently found its way in defense. And around 2021 and 2020 to 2023, you see this just huge uptick in VCs investing nearly across those 3 years, nearly 150 billion. So nearly 150 billion in private capital invested in defense. At the same time as that's happening, over in the public sector, you see this like big push of, hey, we really, across political parties, across government agencies, whether you're in defense, commerce, the intelligence community, everyone's sort of coalescing around one singular strategic challenge. And that's the at the moment, peaceful rise of the People's Republic of China. And so I think that the reasons that defense tech is hot and the reason that the government said, hey, China's a problem, were probably different. But now we're all on the same team. Now we've hit the intersection point. We're all driving towards the same problem. So I think we should really understand that problem well. And I'll break it down like very simply. The leadership of the People's Republic of China, right? The Chinese Communist Party, and specifically their president and general secretary of the party, Xi Jinping, has publicly stated that they have objectives to reshape the international world order that's currently led by the United States and our Western allies, and that they publicly have stated that they would like to reunify with Taiwan. Those are two very big strategic challenges of the United States. And so, from a national security standpoint, it is our job to field the very best military that we can to deter those potential objectives of the Chinese Communist Party. Um, why? So I think that's why that matters and why those two spaces have come together. What does all of that mean next for these spaces? It means that right now we're in a really critical time period to do to bring in that technology and execute deterrence. There are a number of factors ranging from more conflict around the world, economic stagnation and deflation inside of China that's potentially driving leaders to make maybe even rash decisions, and a military on the United States side that is more expensive and by extension smaller than it ever has been. At the height of the Cold War, we had 800 ships under Reagan in the 1980s. Today we have under 300. We said we want 350. We only build 1.5 destroyers a year and roughly the same submarines. The Chinese build 3. So in this present moment, all of those factors have collided. And so not only is it critical that we get these technologies in, there's also just an immense amount of urgency to do so.
What is the current state, as far as we know, in the open source domain of our adversaries' adoption of next generation maritime technologies that would be relevant to the Navy, whether that's autonomous systems or AI or others? And how does the US stack up?
So our number one adversary, as we've talked about a lot, is the People's Republic of China. And they have a concept that is actually, riffs off of the U.S. system of winning the Cold War, called military-civil fusion. Military-civil fusion is the Chinese looking at how the U.S. won the Cold War, which is through by world-class companies in Silicon Valley bringing technologies like the microprocessor to life, and then the government adopting the microprocessor and sticking it into weapon systems like cruise missiles and dumb bombs, and making them smart cruise missiles and very smart bombs. Right. So the Chinese looked at this and said, "Hey, the United States is like really good at the diffusion of technology. We should do that too." And so they developed military civil fusion, which is this idea that Chinese companies work directly for, that their work directly supports the technologies being developed for the People's Liberation Army, which is the Chinese military. And they're doing this across the board in areas ranging from energetics to, rocket propulsion, to AI, to autonomy. And, some examples include in the open source, you can find Chinese specifications for a software-defined warship. In fact, they launched a medium unmanned surface vessel for experimental purposes that meets some of those specifications. So that's a real example of that partnership coming to bear. The good news is the United States is just far better at this, right? We have a long history of taking, innovation and fielding it for military advantage. And I feel fairly confident that we'll be able to continue doing that.
What do you feel like the US most misunderstands about our adversaries' approach to military technology?
Man, that's a tough question. I don't think that there's something we don't understand. I think we're just in the middle. It's hard to be number one for a long period of time, right? The United States has not had a competitor, a peer adversary, since the fall of the Soviet Union in 1991. And today we do. And when I say peer, I mean this is the first time you could really say peer competitor. When you look at the Soviet Union, by scale of military, they were a peer competitor, but in every other aspect of intra-state competition, they were not. They were a near peer. China is most definitely a peer. Uh, the GDP of China is just a smidge below ours. The GDP per capita is actually, far lower, but the actual overall GDP is just below ours. So China is the world's second largest economy. Uh, they are the world's largest navy. They are the world's second largest army. Right? By every metric, they are close to us, and we have no institutional memory of facing a competitor like this since probably the time of the American Revolution, where Britannia ruled the waves and was the global superpower of the day. So since that time, the U.S. has never faced a competitor that could match us and actually exceed us in areas like industrial output. That has just never been the case. And so it's not necessarily that we misunderstand something about our adversaries, it's that we're facing a completely new kind of adversary.
So one of the big topics of conversation that I know you and I have discussed, and I think is a hot topic right now in the broader defense tech community, is what lessons should we be learning from the war in Ukraine as they apply to a potential future conflict in the Indo-Pacific? And what lessons should we not be over learning from?
So I'll start with the easy one is what should we be learning? And it aligns well with what I said before. Software defined platforms are critical, and cycle times of change are faster, largely driven by the software defined platforms. Those changes occur on, we're seeing that across the board on legacy things like tanks, which have to be modified. Like the physical tank has to be modified because of the advent of first person view drones and top down, top attack munitions, all the way to electronic warfare systems. Again, more of a software defined platform than an analog tank. Uh, but the rate of change is just so much faster. And I suspect that any fight in the Indo-Pacific would encounter something very similar in this very rapid rate of change. What lessons should we not be taking away? There's a statistic thrown around all the time that 70 to 80% of Russian casualties today and Russian Ukrainian casualties on the front line are the result of first person view drones. I won't comment on the factual basis for that statistic itself, but the idea that all fires are now based on drones is probably an overreaction and a bridge too far. One of the reasons that Russia just yesterday, from the filming of this podcast, launched over 300 drones at Kiev and just under 70, I think it was 64 cruise missiles, as reported in the Economist this morning, was that Russia can produce more Shahad drones than they roughly at a rate of 300 every 3 days than they can produce cruise missiles. So drone warfare is not necessarily just a function of the fact that this is the new way of war. Drone warfare in Ukraine is a function of what those countries can produce, and I suspect a fight in the Indo-Pacific would look different. Moreover, the fight in the Indo-Pacific will be between large capital assets primarily. Armies are still going to clash on islands, whether that's on Taiwan or other parts of the Western Pacific. But at the end of the day, it will be ships and aircraft that have the lead, and that is just going to be a fundamentally different conflict.
Awesome. Thanks, Artem. Um, as we maybe switch a little bit to the actual adoption, the actual technology and then managing technology adoption, I'm reminded by a story from the turn of the 21st century, a young Lieutenant William Sims, which is a classic case study of the Navy basically rejecting new innovation, right? For the listeners out there who don't know the story, basically this young lieutenant out in the Philippines, stationed in the Western Pacific in 1900, learned about this new technique around continuous aim fire for basically gunnery. The Navy spent a year saying, this is probably not going to work, did their own flawed tests. And it basically took this young lieutenant writing a letter to then Theodore Roosevelt, who was one of the assistant secretaries, to get him to elevate this to a level that needed to be elevated and ultimately adopted. I think there were some wild statistic of a 500% increase in gunnery accuracy in the Navy by this one sort of technique that was initially outcasted. And so I think there's an argument to be said that the Navy in particular, over its history, has had a real challenge when it came to adoption of new technology or just new practices, whether that's because of some of the legacy institutional culture or something else. I'd be curious, one, the Navy's changed a lot since 1900. It is actually in a lot of ways at the forefront of what geopolitically is happening from an experimentation standpoint, and where the potential points of friction, points of conflict are. And so I'd be curious to get, maybe to start off, a high level take on how you would assess the way in which the Navy has tried to adopt new technology or new novel techniques. Where do you think we can still go? If there's one or two areas to really spend our time, spend our focus, if you were going to only had 1 hour or one marginal dollar, where you'd spend that time to enhance and increase that way in which we adopt technology. Artem, sounds like I'll start with you.
I'll start with the last question first. If I had to pick one place that I would change how the Navy adopts technology, I would say that every platform should be software defined, right? We historically, we've heavily vertically integrated our platforms. Whether that's a ship or an aircraft, it's usually made by some large, prime vendor. That prime vendor will deliver the hardware, and that hardware, in order to put software on top of it, will have some sort of proprietary interface. And occasionally the Navy will have data rights, occasionally we won't. Even if we have data rights, we'll have to pay for like the decoder ring to be able to like interface those two things together. And they're very tightly coupled. And unlike an iPhone, or modern consumer electronics, which benefit significantly from vertical integration, we found that defense things don't. So effectively building software-defined platforms on open source like protocols with like open source code is, I think, the future. And we're already seeing this in Ukraine, where software-defined platforms ranging from drones to electronic warfare systems are updated overnight with new code, which in turn leads to some sort of operational outcome. That should be our gold standard. Every night a ship is in contact with an adversary, potentially in a high-end fight, and that ship just gets better because we deploy new code to it. So that's the one kind of vision of the future I have. Going back into the past, the Navy has struggled with technology adoption. I think the Sim story is just one of dozens. And I would point to kind of three high-level things of what makes working with the Navy potentially challenging from a technology integration standpoint. The first is that large capital asset bit that I mentioned earlier. 70% of the Navy's budget goes to the ships, aircraft carriers, submarines, airplanes, etc. That's different than the other services. Akil, you're a Marine. 65% of your services budget goes to humans, right? So we're used to buying things. We're not used to buying software. And the second is the Navy has a unique culture of, kind of bottom up innovation. But that means that, top down is hard. And that dates back to the notion of independent command at sea, and the idea that, ship captain goes over the horizon and loses communications with everybody, and just has to make decisions on their own. That's created kind of a centralized command and control system and a very hierarchical approach to like how our service operates. That's hard. We're working on getting better.
Thanks, Artem. I wanted to pick up quickly on your software-defined portion. One, I think spending more time in the space, I think folks sometimes get what software-defined means to be actually wrong. So I want to really, really distill what to you is software-defined in the military context. And maybe as part of that question, you talk a lot about open source and being able to iterate constantly. Are we always going to be at constant tension with the DevSecOps process of how we ensure whatever that means on the security side, with our ability to continuously iterate and ship and commit code on a nightly basis at scale?
Yeah, so software in the military context, software-defined warfare refers to the idea that your hardware platforms are getting better on a rapid, rate. So in hours and days, vice months and years, because of the deployment of software to those hardware platforms. So just like a Tesla or your refrigerator potentially gets a software update overnight, and that piece of hardware now has new functionality, we won't want to see that in the military domain. And adaptation is, the side that adapts the fastest in conflict wins. Historically, adaptations came in the form of doctrine, tactics, techniques, procedures, or potentially rolling out a new technology. The tank replaces the horse. Today, adaptation means deploying code, and in turn, the deployment of code drives those other changes. It drives tactics, techniques, and procedures. It drives doctrine. It drives training, which is it's a new paradigm, and it has really changed the character of war.
So building off of that just a little bit, Artem is invoking both Darwin and then Krepenovich, right? And so this goes from the species to the origins of victory, all the way to getting very wonky, like .mlpfp. Here's the point. Maneuver warfare became the primary mode of marine philosophy, essentially, like execution, 1989. That scaling out and applying to technology as we've watched the wave of software grow is something that needs to be more tightly approached. And so what we've seen there is that this OODA loop that so many people talk about is very measurable in terms of how long it takes to adapt. And so when you mentioned Sims looked at the 500%, there's a lot of talk, there's a lot of activities, but ultimately the time it takes to turn a ship or the time it takes to change the way that we are defending or countering is a very measurable thing. And so we talked about software-defined warfare. Obviously, that's the fastest moving piece. I'd say just extending that a little bit, modular across the board is particularly important. So depending on how we do interfaces, including hardware, the more of these components that are swappable, the better. So we have a new line of shipbuilders, the ability to navigate for autonomy or with or without GPS are open questions. The idea of doing this vertically is an open question. And so we've seen some success with, for instance, InQtel taking Anello Photonics and saying, hey, instead of your alt PNT solution, swap that out and then swap in this new piece of hardware. Like that ability to mix and match all the way through hardware is ultimately something that I think is going to be extremely important to adaptation. And so we have a few adaptation cells. We have one that we work with within the SEAL community. We have a few back office technical teams, and those are days and weeks mix and match. That's extremely important, especially if we're not getting live production contact. And so I would say that watching this and being able to make those trade-offs in real time is something that is allowing this bottom up to be pulled all the way through, something we already knew. There are often really good solutions closer to the problem, right? You're more likely to solve a problem if you're in it than if you're in some building far, far away. But how long does it take to make through, and how many letters do you have to write to Congress or somebody else? Well, we want that to be more data driven. There's an obvious difference between private sector and public sector. Public sector is not measured on return on investment historically. There's no good sense or way of doing that. And so when you say something is 5 times better, that's really impressive, but like the denominator is not standard at all. And so we've standardized the denominator to say if you are changing outcomes in a significant way, it's less important where the solution comes from in terms of where in the stack, and more important that you're moving the needle for the warfighter. And so like a tactical example of this is occasionally we'll use KPIs that specify how something works in the requirements document. And so we'll say there needs to be this upload speed and this download speed, but also we're specifying that we need coax cable at this installation. And the reality is we just need connectivity. And so what we've recently done is allowed for proliferated low Earth orbit and 5G to compete with traditional wired. And so all this across the board, hardware and software, where outcomes are the basis for acquisition and scaling decisions, everyone is better off.
Could you give a story of a time when fielding a software-defined system really made a difference in some environment?
I think the best real world example for today is Ukraine. We brought that up, but I'll use a relevant example from the U.S. Surface Navy. Our ships since October of 2023 have been engaged in active combat operations in the Red Sea against the Houthis, which are an Iranian-backed militia movement in Yemen. That means that our ships, for the first time since World War II, have been under, inside of the weapons engagement zone of an adversary for a consistent period of time. And so we've, at the filming of this podcast, we have engaged roughly, 300 plus air breathing threats. So that's a lot of data points. And at the start of that conflict, it took us weeks to get data off our ships. We have since gotten that down to days. We want to get that down into hours. And the data from those ships has improved. When it gets back to CONUS, to the United States, it has improved everything on the spectrum from the tactics that those ships are using to shoot down those threats, all the way to the actual radar systems on board the ships, where we have analyzed the data, sent a software update back on a CD. Ideally it would go over the air, but baby steps. Sent it back to the ship, and the ship's radar systems have improved. So that's just one example of a software-defined, platform yielding a measurable, impact in combat.
And so there are EW cases. There are also just infrastructure and connectivity cases that kind of allow everything above those to improve. And so we weren't doing a ton of telemetry a few years ago. And so at this point, the way this works, CONUS and OCONUS, is we're watching those flows proactively. And we can do a cyber example after this. But now, instead of using phone calls or emails as the trigger for where connectivity problems exist, we're extremely proactive, and we can do hot swap redirects or load balancing proactively. And so in this particular case, this is a re-envisioning on how we modernly manage the highway for which all of the cars and bits and flows operate. I would say that prior to a couple of years ago, that wasn't pro grade, and now it's first in class.
As we talk about fielding more of these software-defined systems, what does that mean for the current capabilities that we have? Does this mean we need to throw away all of our aircraft carriers and F-35s and field just armies and armies of USVs and UAVs? Or does it mean something different? And if it means something different, how do we envision kind of the future of this software-defined force?
I really love this question because we hear this. The Navy gets this, I think, more than the other services because we are so platform centric. We get told all the time that, hey, the character of war has shifted towards autonomous systems that are software defined. You can just throw out all the expensive manned things. The F-35, there was a prominent tweet that suggested those could be replaced. The $135 million F-35 could be replaced by the $10,000 hobbyist drone. And that just isn't the case. What we have found in our war games is that generally when we face off against a peer competitor, that is usually the People's Republic of China, our program of record force, meaning the things we have today, our aircraft carriers, ships, submarines, etc. Uh, you know, occasionally win, occasionally lose. We want to win every single time. And when we wargame that same scenario and add these new capabilities, these software defined capabilities in a hybrid fashion, so the traditional manned platforms operating with an unmanned system. So think an F-35 operating with a collaborative combat aircraft, a large Navy destroyer operating with a medium unmanned surface vessel, which itself has a fleet, its own little flotilla of small unmanned surface vessels. When we wargame that hybrid force against the People's Republic of China, we come out on top more often than not. And so that's the surface Navy strategy, is how do we field the best hybrid force? And if you and we've had that consistent message for a few years now, because we recognize that you're not going to replace these large capital assets, but you need kind of a high-low mix, which is a Cold War term of a small number of high-end exquisite platforms and a large number of low-end attritable systems.
And so that barbell strategy, I think, applies a number of different places, right? Ultimately, it's as much an economic strategy as it is a technology strategy. But where that plays out or where that bears, I mean, we can double click on kind of any domain. And so let's say from a logistics perspective, how many different government off the shelf applications do you need? Ultimately, the way that I'm viewing this, and we have a number of now memos and invitations to say, uh, let's just not let's not just let commercial in, but let's do one to many replacements. And so we're piloting capabilities, the commercial capabilities, but they go so much better when someone says, here are the 7 aspects of logistics IT that we can wipe out from a GOTS perspective with one COTS application. If we don't have time for BASF to harken back to the early 90s that says we make everything a little bit better, but we don't replace anything. That's not good enough. And so we are looking for divestments across the board, even if they're not apples to apples. I think another example of this is, and this is software defined, but in a perhaps like with a little twist. I recently was with the strategic submarine PEO, and they were looking and working with Gecko Robotics. Within that Gecko Robotics example, I said, what are you replacing? They're replacing manual action. They're replacing services. They're replacing, and with that, getting both productivity gains and security or safety gains. So safety. This is a place where between maintenance, the cleaning, and then manufacturing, we had one way of doing things. And we would like to open the door to say, we will give you our problem, you figure out, or we will give you how we're doing this right now. And instead of just incremental improvement, what is your Horizon 3 solution for doing this differently? The hardest part here is, again, it is not intuitive that there are incentives for people to change the way that they work. And so we know that there are mavericks. That is a 10 to 15% of any organization is willing to work against their own self-interests for the better good. We have an incredible mission, like one of the best, possibly imaginable. And so we've catalyzed that into, let's say, 15 to 20% of groups that are willing to do more work and adopt commercial or think creatively about something. It's almost always more work at first, both for the company who is bringing that in and the PM and support staff who are having to reimagine all of these different pieces, because most people would prefer to do things the way that they had always been done, right? And so if there are more groups who want to be pilot leads and who want to accelerate commercial adoption, then I would say that there's Steve Spear, professor at MIT, says great organizations always look for the suck. there's suck in every organization, and you can always find weakest links. So if we're doing this quantitatively and we're saying, either look at the numbers or talk to a sailor marine, where are the pain points? And then how do I extrapolate that up to a solvable technical problem and then scale that across the board? We can have fewer systems that perform at a higher level, and that's going to be a combination of hardware and software. But this is a time for reinvention, and we can do that quantitatively, even if that's from the outside in. So flipping, so it's more private than public sector. We are pulling them through, or this is like the point earlier, this is someone at the ground floor who sees something, tries it, and then we scale that. In both cases, we now have the ability to stamp something as an enterprise service, and this is across the board. Those can be apples to oranges as long as they have calories, as long as they nourish. We're ready to make those trades.
So I wanted to ask, this is kind of on an earlier point that we were talking about in terms of integrating these new technologies with our existing program of record force. I want to see if one of you guys could maybe tell a story of a startup or company that did a particularly good job doing that. And, maybe what were some of the steps that they had to get through? Like, step one, what's required to even integrate with a data source coming off of a ship or an aircraft carrier? What's kind of, hardware edge compute constraints do we have or access do we have? What kinds of AI models do you have? What kinds of data do you have? I know, Artem, one of the things we've talked about is computer vision and some of the challenges of doing that at sea. So I want to see if maybe you guys could just give us like a life story, life cycle of what it looks like to actually integrate a system with the program of records force that we have today.
So I'll start with saying it's not a 0 or 1. Like you're not totally air gapped and you're not totally integrated, right? There is a spectrum in between. And I think the success stories we've seen in the last 2 years are sit in that middle area where we've delivered some kind of, in the case of computer vision, some CV models to our ships, and those models, live and operate in inference on commoditized commercial hardware, and that hardware, in most cases, is air gapped from the rest of the combat system. Uh, is the best thing possible, like for us to connect those? Absolutely. Is Could we deliver the commoditized hardware and the model to the to run at the edge in a month, as opposed to going through a 3 year long integration process? Yes, and so that's why we chose the like in between solution, where an operator is kind of looking at a laptop as opposed to looking at like their display in the combat information center as part of the Aegis combat system. So in that particular example, that's a like in between integration story. But we've also seen examples where we've done the full integration work from start to finish to bring some AI models to our combat system, and that involves working with the prime contractor that delivers that combat system. That means the working with a third party that does the integration work, because that prime contractor's code is in like Ada or in 4chan, which, like, for those that don't know, that 4chan was the DoD's like proprietary code base. Um, the So that's why you need like all of those moving pieces, and that took a couple years. I'm being non-specific on the industry partners just due to the classification of the work involved, but the uh, we've done both. We're doing more of the first, and the first is what I urge most like startups to do. Right, startups want to get a product out and make sure it's usable, or get an MVP out. You're not going to integrate with an F-35 or an Arleigh class destroyer in a month. So get some standalone hardware that maybe has like one integration point with, like, if you're moving data, maybe you use the ship's routers and switches, but you're not tied into the combat system. Or you're delivering a model, but you're running on your own hardware as opposed to the ship's hardware. Uh, yes, that's a limitation of working with the Navy, but I think it's one that we're working towards overcoming.
And then on another ship example, but not weapon systems. Within Canes, there's virtualization. And so we have VMs that have done a job, a
Justin, what's
specific.
Canes?
Oh, sorry. The Consolidated Afloat Network Enterprise System Solution.
I think
Yeah,
services.
services. Okay, makes sense. Sure. So the Consolidated Afloat Network Enterprise Services. This is the largest shipboard network, and it's where between some nipper and some sipper, so some unclass and some classified functions, that we have a lot of different capabilities running on one backbone and one set of computing. And in this particular case, we have taken some of the capabilities that are virtualized and tried to, in a lab, uh, find more efficient ways to do them. Again, one for the price of multiple, and swap those in. And so we've now unleashed some COTS vendors to look at a native capability within Canes and replace that in a virtualized fashion and just kind of hot swap those. And so that's something that we're getting a little bit better at. We're also doing that with Flank Speed Edge, that more modern hardware. And so between those two, here are ways that we can take external software capabilities and pull them in and lower the time to integration on that. That is, to me, repeatable. And then this, I want to call back to the initial point where we said like integration can go way differently. When I started doing that type of work 18 years ago, when I was actually doing ship installs, we had a binder and you had to follow all of these steps, and you're in the operating system and you're swapping from Solaris to like other like lower down components. How all of that goes forward is something that we've toyed with streamlining. I think that looks very different in the next year, and to this point, when we look at what can be replaced, the more that we sandbox that up and the more that we can invite people through structured challenges to figure out what they can divest instead of doing a one-for-one request to divest, then this becomes like downhill running.
What do people outside of the Navy or the Department of Defense most commonly misunderstand about Navy or DoD tech adoption as a whole?
Uh, I think I know we've talked so much on integration, and I hate belaboring this point, but I think people really misunderstand how hard it is to put something on a warship. You are not just like, you're not bolting a computer to the side, right? I mean, even to upgrade, Justin at some point talked about the afloat OT and IT infrastructure on ships. To replace that, that means cutting a hole in the side of the ship, taking out a bunch of server racks, and then putting them back in. That's not like a week-long process or a month-long process. That's a 180-day long process. And so technology integration with the DoD is hard. Um, it's not just hard for the technical reasons I just described. It's also hard because of our risk tolerance. Remember that when you're delivering, if you're a startup and you're delivering a capability to a warfighter, that means that there's a human being, an American sailor, soldier, airman, or Marine, or Guardian from Space Force, who is potentially in close contact with an adversary trying to kill them. And so our risk tolerance and our threshold for something working is just so much higher than deploying an app and it being buggy and potentially not working, and you losing some stock points that day on the Dow. Uh, because of that higher risk threshold, um, we are going to do test and evaluation in a way that maybe mimics industry in terms of process, but has a longer timeline and has some extra steps. And you really have to think carefully about how that technology will be used, especially when it fails and what failure looks like, because failure could be catastrophic.
So you're telling me all DoD software completely bug-free, running perfectly smoothly?
Yeah, it's excellent in every regard. Um, no, in fact, what I'll say is the DoD sometimes mistakes um, process, like the process through which we follow. Like, let's say you're getting an authority to operate an ATO, which means your application has been designated as like cyber safe by the DoD because we like read all of your source code. And then we've like now, like a human being read all of your source code, and then we deploy it to a secure environment. That doesn't magically like mitigate cyber risk. Similarly, writing a requirement by committee and having like 10 people on the committee like say thumbs up to the requirement. In the Navy, we call them requirements and resources boards. Uh, that doesn't like magically de-risk the technology. And so I would say we mistake our processes as being risk mitigators. And true risk mitigation is like a very sound technical implementation.
Are there any special considerations that startups need to consider when building for the Navy as opposed to some of the other DoD services?
The Navy is very, uh, again, because of our large capital assets occupying most of our budget. And large capital assets are not built by startups, they're built by traditional prime vendors. And the defense primes refer to companies like Lockheed Martin, Raytheon, General Dynamics, Boeing, etc. Uh, when you build for the Navy, you really have to think how your technology is going to interface with the technologies made by those vendors. You're not just building to interface something with a common API that you can just find the API key online and you're like good to go. You're building on top of, decades of legacy hardware and software. So you're going to have to, we talked about interfaces are hard. You're going to have to really work with those prime vendors and build partnerships at like a human level with those engineers who, painstakingly over the course of decades have built the world's strongest military, um, and today are also striving to bring in new technology.
Artem, one of the major themes that we have been discussing this conversation is how do we get commercial technology that we already sort of know works or more or less works into the Navy and the Department of Defense. Can you maybe share an example of a technology that we think of as mature, but that maybe has some unique considerations or challenges when applied to the maritime domain?
Yeah, a problem that's really near and dear to my heart because of my time working on, supporting Maven is computer vision. And I think that this is a largely believed to be a solved problem in Silicon Valley, right? AlexNet 2010. Since then you have, I mean, almost everything, whether it's your iPhone or your vehicle, has like some sort of CV model like running very effectively with like just great F1 scores. You're detecting everything. And we think of that as a solved problem. Well, when you pivot that same technology to the maritime domain, it is absolutely not a solved problem. It is on the cutting edge of DoD AI problems because, for one, you don't just have thousands of ships going around with cameras producing, model ready data that you just feed into an open source model like YOLO v10 and say like, oh, look, I now have computer vision at sea, right? So you have an absence of data. You're also not, you're also dealing with like a really unique environment with significant background noise, atmospheric changes that you just don't encounter in the regular just if you're a car driving down a street. So really great example, computer vision in the maritime domain of a commercial technology that is a solved problem, but requires some additional steps when you're looking to work with the DoD. And this is why partnership is just so important, right? The DoD is the world's largest. I'm not 100% certain on this, but I feel confident enough to make this statement. We own the most data of ships floating in the ocean. I feel fairly confident in us saying that. And so you want to do CV for horizontal motion imagery at sea, come work with the DoD, right? There's a partnership. Figure out which prime vendors you need to partner with because they're the ones deploying those electro-optical or infrared sensors at sea today. And then figure out which government labs have dedicated, decades of research to this problem that potentially, it doesn't have a commercial application today, and so a normal startup just wouldn't go after it. But the government labs, which have those like long 10, 20-year horizons, did choose to go after it and have done a lot of like great research to really, help us field these capabilities.
So now this is a question I have to ask because I'm sitting in San Francisco and all anybody ever talks about is generative AI. Where are you seeing the most interesting and exciting use cases for generative AI in the Navy today?
Man, there's so much I can say about generative AI. All right, so the first is that um the government is not immune to it. There are no special use cases that are exclusive to the government on generative AI. Most of the things that are adding value in the commercial sector, I would say like RAG as an example, right? Basically search your own documents, or in some cases, right, search your own knowledge base. So instead of doing a SQL query, you're now having a conversation with a model. Those are like the areas where the government is seeing the most use, which is a one for one, analogous to what we're seeing in the commercial space. Uh, how do I see generative AI more generally in the competition between the U.S. and China in the military space? I think is actually a more interesting question. Um, the United States labs, such as OpenAI and Anthropic, have really been focused on the model, um, and really being on the cutting edge of model development. In China, with the exception of the innovations we saw with DeepSeek R1, you're seeing a lot of emphasis on the actual commercialization of the technology, and that's a problem because historically, if you look at how a technology, especially a generalizable technology like our electricity and today like AI, has won a great power competition, it was not the country that developed the technology first, or even the country that refined the technology first, that won that great power competition. It was the country that was able to uh, diffuse the technology and yield outsized economic benefits as a result. And I'm not so sure whether you're a shareholder of a Fortune 500 company or you're the leader of a government agency such as the Department of Defense, you're really seeing that, significant return on investment today, or the diffusion of that technology today. Conversely, in China, you're seeing significant diffusion of AI into all sorts of technology verticals. And that doesn't bode well for long-term great power competition.
So I want to pull on a few threads that you all mentioned. We heard about the mission, we heard about wargaming, the People's Republic of China. I want to take a step back and really set the stage here. Why does all of this matter in the first place? What is the state of geopolitics with our adversaries? What is the Navy's role in a potential conflict? And why does it matter for us to rethink the way we design our force right now? And is there a sense of urgency?
There are still folks who are clinging on to building things in government that probably shouldn't be anymore. And so we've explicitly stated that we're going with a fast follower first strategy. As acquisition, as the 18 program executive offices within Department of Navy, 5 of them have shifted over to portfolios so that we can make better buying decisions based on capabilities and effects. As that shifts, we want to both reward the people who are contributing from every aspect of that, as well as the ones who are actually doing, making the difference. So doing what we have requested, and what the Secretary of Defense has requested, and what the President has requested. And so the PM of Lionfish Small and Prime Small USV and Dragonfish Large UUV. These are cases where PEO, USC, and UWS are trying to pull in different things and that may even compete with something that's happening in a lab or internal development. But those shifts right now are either going into overdrive or we're not moving fast enough.
Yeah, Justin, thank you for naming a few folks that you're seeing who are really doing a good job right now when it comes to fielding the systems that we're going to need in this increasingly geopolitically complicated world. I wanted to see, could you maybe tell us what about those organizations has been so successful, and what can the rest of the Department of Defense or the Navy learn from some of these success stories?
Yeah. So number one, trying to do something new alone. The first time that we endeavor, it rarely works well unless we have a really strong partner. And so in all three of those cases, um, uh, Captain Alex Campbell at DIU was involved. This is a person who gets it. This is a person who is bringing the weight of that organization, who has been interacting with industry in a mature way. And they found, and it doesn't take, sometimes people think it takes like a whole program office to agree. Really, what I've seen is it just takes one 04, 05, 06, or a courageous civilian to say, okay, we will figure out how these compare. And we will show that even if it's not a perfect fit, there is likely a requirement or capability need statement that will allow us to do things differently. So translating the technology into outcomes where this is affecting the outcome in a more significant way, we can give top cover. I'll use a really specific example. We had an '06 who was a CSO on a carrier, and he said, "Send me what you're doing for the ashore systems. So send me a hyperconverged infrastructure stack to my carrier. We'll deploy that." And there was a lot of paperwork, like Akil and I were talking about, like there always is, because this is not how it's supposed to work. But sometimes people get bogged down with um, emphasizing every aspect of process as opposed to the outcome. And so this was a combination of heads down, nugging through. It is always more work than you expect, and then wavering and justifying. And part of the ways that we wavered and justified is we showed the difference it was going to make. And so this isn't just hey, we need this, or we're the loudest voice, or these are two senior people working. This was, here is the baseline for connectivity on ships right now. Here's what that's doing from a quality of life and quality of service perspective. And here is the difference that we can make. And so that jump, that leap, was something that still required WASTA, but we had the numbers. And so if Captain Kevin White made that happen on one ship, but my belief is that it was the documentation that we had coming out of there that showed that, hey, this is 1,000 times better for connectivity, and for, in this particular case, is significant improvements in user experience, one of our outcome-driven metrics. That carried us into 5 more carriers afterwards. And then Flank Speed Wireless, the capability that we're talking about, aka SEA2, Sailor Edge, afloat and ashore, is something that is turning into a full-on scaling capability.
At a really high level, just super quick, the best partnerships in government, like to get tech in government, are obviously partnering with commercial. That's a given. That's partnership number one. And then inside of government, you need kind of three groups, right? And then the end user, meaning the warfighter, the sailor on a ship, the marine in the field, the airman on a maintenance line, and then you need the acquisitions community to help you bring the commercial thing in, and then you need a resource sponsor. So that's somebody sitting in the Pentagon that's willing to do the mountain of paperwork that Justin described in order to make sure that this capability that is clearly measurably better than what we had before actually gets into the budget and stays funded for the long term. You have to have all four of those, and I think we've become really good at the flywheel effect of building those teams, and those private public partnerships.
If you had a single slide to articulate one metric for your respective office, what would that metric be?
We're in the government. We love slides. If I had to pick one thing,
I know.
uh,
I
it,
asked you for a single, one slide, not 40 slides here.
we if I had to pick a metric, it would be how few slides we use to get something across the finish line. Bit of a joke there, but I would say today we measure things by what Justin hinted at: cost, schedule, performance. And cost is how expensive a thing is. Did we go above or below budget? Schedule is, was it delivered on time? Or usually the answer is no. And performance is, did you meet a requirement? And what that means is, did you meet the mark according to a piece of paper that was likely developed 5 to 10 years ago? That isn't how we want to judge success. We want to judge success by operational outcomes. And so if it's a piece of software, if it's a facing piece of software, operator input would be like number one, meaning like, here's how I used to do my job. Here's how I do my job now, because, right, like you're delivering a software application. The process is the product. You're changing how that operator is doing something. And then number two, closely behind it, would be like the real world operational impact. If I'm delivering a new, let's say, command and control user interface for unmanned systems, was I able to a group of sailors, were the sailors able to control 10 robots before this and now 20 robots, and now the robots can swarm because it used to take 10 clicks, now it takes 2. Those are the kinds of metrics that I'd like to display on that slide: user facing and operational outcomes.
Can you tell us about a startup, or maybe a VC-backed startup, that has been particularly successful building and deploying technology for the Navy, and what can other startups learn from what they did in order to achieve success?
When you say building and deploying technology for the Navy, let's talk about cases where like they're building and deploying capability and the Navy is making use of that. So maybe Project Ammo for ML Ops, where we had a decent amount of in-house software and then kind of like a coagulation of COTS. We had companies like Domino Data Labs and Latent AI that were doing commercial work that said, we do this for pharmaceutical and healthcare. We can do ML, we can do machine learning operations for defense functions better than you can build something up yourself. And so there was hey, meet this team, work on this problem, take a look at our algorithms. And so that relationship grew. They showed the difference that they were making. They brought that business mindset where they could show, here is the difference that we're making. And then they did something else that is an unlock, which is they found other people's money to apply to the problem. And so they applied to the AppFit program and got a plus up there that was significant. That helped certainly the Navy, hopefully also the Marine Corps. And as that group showed the difference they were making, understood who the players were, applied their knowledge and experience from other sectors, and then found funding for that valley of death until we can get them into the larger scale, like sustainment budget. Like those are the big factors for how they can make that difference. And now they've also bought enough time to show here are how outsized effects can come out of their next batch of work.
I'll use two really quick examples. One is a hardware example. The Navy brought in Saronic to build the Prime, which Prime is a DIU, Defense Innovation Unit contract for small unmanned surface vessels, SUSVs. A year ago, we did not have, thousands of attritable SUSVs. A year from now, we will. When we actually ran the Prime solicitation, Saronic had not built the Corsair, which is the boat that the Navy is buying in mass. So, in fact, that company actually did not exist 3 years ago. And the idea of using a small, fast-moving boat to blow up large capital warships didn't exist, in the same way that it does today. And so Saronic is a great example of a hardware company that the Navy has brought in, adopted the technology, and is now developing the tactics and standing up. We've actually stood up 2 unmanned surface vessel squadrons, so 2 new units that didn't exist. Even one of them didn't exist a month ago. So that's the rate of change here. And then the second, a software example that's like really a success story. Justin mentioned ML Ops. I'm an alum of something called Project Maven in DoD, which was the application of computer vision to overhead intelligence gathering satellites, overhead imagery satellites. Um, the success of Project Maven is that the government set up a data environment and gave a bunch of industry partners, ranging from large companies like Microsoft down to small startups like Modern Intelligence, access the same data and said, compete and build us the best models. And so that's a success story for 2 reasons. One, we brought in a bunch of new entrants into the defense industrial base. Companies that previously wouldn't have been able to work with the Department of Defense were, because of the technical implementation of this program. And the second is we're bringing market forces into government, right? So instead of competing, usually the government can have one program of record to build a missile. Well, wouldn't it be great if there was one program of record, but like 5 missile vendors below them, all building and competing with each other? And that's the environment we set up for Maven for the delivery of computer vision models into DoD, and that is now the joint program of record for automatic target recognition in the department as a result.
Justin, and Artem, as we're kind of coming up on time here, I wanted to come back to maybe your thoughts and perspectives to give to the startup and sort of industry community. Artem, I thought you made some great points about aligning the right incentives between venture capital that's spending more time in the space, the government that has a real need based upon geopolitics, and industry who wants to get involved either because of the mission or something else. Sometimes those alignments can be a little bit unaligned. And so curious to ask you a little bit, maybe just generally, I'm a new startup in this space. What are some pieces of advice for startup founders in particular that might be thinking about getting into the government space or working on a really tough and important national security problem set?
I think it might surprise folks, but the best piece of advice you can give any startup founder, I think, is always know the problem you're solving, and really like know the people whose problem you're solving. That isn't always super obvious in government. Uh, when you look at the government and you look at the DoD is the single largest employer in the world, right? So, where do you even begin? Like, who is your end user? Which problem? Let's say you're really passionate about solving an electronic warfare problem. You could go talk to a requirements officer in the Pentagon, somebody at the Washington Navy Yard that works in a program office that buys things, or like a Navy SEAL at a unit somewhere deployed in the Western Pacific. All 3 of those could potentially be some semblance of an end user. So it can be challenging to figure out who you really need to talk to. I'd say my number one piece of advice is start with that person closest to the edge, right? The operator in a camouflage uniform, ideally on, active duty orders somewhere forward deployed, is the end user, no matter what. A program office will tell you that they're not responsible for buying things, like the person at the edge isn't responsible for buying things. That's okay. You should still be talking to them because that's whose problem you're solving. And the second piece of advice is that it's going to be a long game, right? Defense is slow moving capital, right? We operate on what are called 5-year, or sorry, FIDUPs. The Justin, help me out here. What's the F? It's not 5, but
Financial, right? Financial year something.
Future
future years
year
defense plan,
Future.
right? So we operate on these like long capital cycle times. So recognize that if you're solving a defense problem, not only are you choosing to solve one of the hardest problems out there, both from a technical standpoint and from a delivery of a capability standpoint, and also some of the most important problems, I might add, you're also dealing with slow money. So persistence is going to be key. And I would say those are my 2 big pieces of advice.
On that last piece, it's you have to be impatiently patient or patiently impatient. This to say, like, even if it's slow, there is work to do every day. And I would put a bulk of my effort talking with people who get it. And so whether we're using Unleashed or Mavericks, or if they are thinking about problems traditionally, you're unlikely to change their mind. If you want to spend time talking to people who have done things the other way, that is good community service. But if you find people who are fellow travelers, who are wanting to be commercial adopters who are disruptive, you will notice that, and that's where I would dedicate my time. It's a kind of like a table stakes to have something that is too good to be ignored. It is table stakes to, in my opinion, have something that you can turn off. When you find what you're solving and you're close to that problem, and you have people with the light bulb over their head and they get it with you, then work with them to denote what is severable and what you can carve out in fiscal year 26, fiscal year 27, fiscal year 28, until we get that refined budget. And so we should be turning off or replacing capability and solving problems at the same time. So you have to do the gain creation and the pain reduction at the same time in order to walk the walk. Otherwise, you have to tell your investors, hey, they really like it. We'll see something in 3 years. If this is a contact sport, if you are not severing something in the meantime, then you're probably at the wrong part of the stack.
If you were granted 3 wishes from a genie and you could only use them to advance the state of DoD tech adoption, what would you wish for?
Do we both get 3? Or do we get 3 total?
Okay, you guys can both get 3.
All right.
That's
if
a
we
nice
both,
genie.
That is a nice genie. It's like there's a queue for the genie and each person gets 3 wishes. This is great.
I think we should have to neck down. I think we should both get 3 and then decide a consensus 3.
I like that. My number 1 is that that every program manager in the government is tied to the hip to an operator that is ideally like under the age of 30, just like brand new, has not seen how we've always done it, and is just eager to like try new things. And so that each program manager, 1, is tied to the hip to an operator, so they're solving that operator's problem. Number 2 is that program manager is doing it with commercial tech instead of looking at something in a government lab or looking to do like a 5-year or 10-year acquisition. They're looking to like bring in a thing that's ready to go off the shelf today. And the third is that the government has more flexibility. And specifically, when I say the government, I mean the executive branch has more flexibility to move money around inside of the execution year. And what that means is, Justin talked about like fiscal year 28, 29. That's like where our heads are right now. Like when we're in the Pentagon, we're thinking about those, what we're going to buy 5 years from now. That's kind of a ridiculous model. We should be thinking about what we want to buy right now, because we don't know what the tech's going to be 5 years from now. So I hope that Genie lets me move different, money around today to divest from legacy things and recapitalize that money immediately to a new thing, using that program manager that knows commercial tech and is tied to the hip to an operator.
I think those are really good. If there's anyone who's listening to the show who either has done Maverick things that we haven't documented or wants to, please reach out to us on LinkedIn if you're outside, or Teams if you're on the inside. We want to expand the Unleashed base so that we can show just a compounding return on investment from hearts and minds to effects across the board. Now is the time.
Thank you guys so much for coming on the show and sharing some of these great success stories.
Thanks for having
Thanks,
us.
Justin. Thanks, Justin. Thanks, Artem, for all you do. Hey, everyone. Thanks for listening to the Mission Matters podcast from Shield Capital. Tune in again next month for another conversation with founders building for a mission that matters. And if you yourself are looking to build in the national security space, please reach out to us.